Welcome back to class. In our last lesson, we explained discriminants and nature of roots. In this lesson, I have a question that can further help us understand nature of roots and how to apply them. That said, let's get into class. Come back. Now, in our last lesson, remember we said if I have ax squared plus bx plus c equals to 0 as a quadratic equation, I can solve this equation simply by using a formula. The formula tells me that x equals to minus b plus or minus square root of b squared minus 4ac over 2a, where my b squared minus 4ac is referred to as the discriminant. The discriminant will help us determine the nature of roots. Now, the discriminant, so that I can now rewrite this as minus b plus or minus square root of d over 2a, so that the discriminant d here determines the nature of the root of this equation x squared plus bx plus c. Now let's look at this question. This question says that I have h of x to be equals to 2x squared plus a plus 4x plus k. Now I'm to find the discriminant of h of x. Remember, the discriminant d is given as b squared minus 4ac. In this instance, my a will be the same thing as 2, my b will be the same thing as k plus 4, and my c will be the same thing as what? As k. So that my discriminant d will be given as a plus 4, yes, k plus 4, let me write that properly, all squared, because that's my b, minus 4 into a. My a is 2 and my c is k. So that my d now, on expanding this, will be the same thing as k squared plus 8k plus 16. Now minus 4 times 2 times k, that's minus 8k, plus 8k minus 8k, so that my d obviously is k squared plus 16. So the first question has been answered. Define the discriminant of h of x. The discriminant of h of x is k squared plus 16. Is k squared plus 16. Now let me create space here to solve the second question. Now remember that the equation ax squared plus bx plus c is equals to 0 is governed by x is equals to minus b plus or minus square root of d over 2a. Now, to show that this has two distinct real roots, we'll be able to prove that for every value of k, when k is greater than 0, that is, when k is greater than 0, k is positive. It could be that when k can be 1, 2, 3, 4 continuously, my d will be the same thing as, if k is 1, that's 1 squared plus 16, which is going to be greater than what? 0. Or let me put it this way, my d, when k is greater than 0, my d will always be greater than 0. So the roots are distinct, are two distinct roots. Now, when k is less than 0, that is, when k is equals to probably minus 1, minus 2, minus 3, my d again will always be greater than what? 0. Because if k is equals to minus 1, that's an example. If k is equals to minus 1, my d will be the same thing as minus 1 all squared plus 16, which is equals to 17, still greater than 0. So as long as d is greater than 0, I must have two distinct roots. That's one of our proofs. That was one of the conditions in the first session. Now, let's see the third part is when k itself is equals to 0. When k is equals to 0, my d again, which is same thing as k squared plus 16, will be the same thing as 0 plus 16, which is equals to 16. So we've seen that k at every point, or d rather, we've seen that d, when k is greater than 0, d is greater than 0. We've seen that when k is less than 0, d is greater than 0. And when k is equals to 0, we've seen again that d is still greater than 0. So for all values of k, h of x has distinct roots. Each of x has distinct roots. Now, with this, I hope you understand nature of roots of quadratic equations. Thank you for staying with us and see you in our next class.